The lymphatic system has four functions. The first function is fluid recovery. Fluid from the capillaries can accumulate in the tissue spaces. This is prevented by the lymphatic system that picks up the excess fluid and returns it to the general bloodstream. The second function is absorption of fats. Lymphatic capillaries absorb fats at the small intestine. The third function is the production of lymphocytes. There are two types of lymphocytes, T lymphocytes and B lymphocytes. The organs of the lymphatic system produce these lymphocytes. The last function is the storage and mobilization of lymphocytes when there is an infection. Lymphocytes are stored in the lymph nodes, and when there is an infection, they must be mobilized and sent into the general circulation. Let's take a closer look at fluid recovery. Here's a blood capillary. The red side is the arterial end, and the blue side is the venous end. Water comes out at the arterial end, and water returns to the blood capillary at the venous end. Inside the blood capillary, the fluid is referred to as plasma. Even though there is movement of water in and out of the capillary, a certain amount of fluid ends up in the tissue space. This excess tissue fluid can then be picked up by the lymphatic system. Once it enters the lymphatic capillary, this fluid is now referred to as lymph. The lymph then travels into lymphatic vessels. There is a lymphatic vessel carrying the lymph into the lymph node and a lymphatic vessel carrying the lymph out of the lymph node. So the area that is expanded in the center is the lymph node. From the lymphatic vessels, the lymph then flows into the lymphatic trunks. From the lymphatic trunks, the lymph flows into a lymphatic duct. The lymphatic ducts then send the lymph into the subclavian vein. Here, the fluid is now referred to as plasma. And from the subclavian vein, the fluid returns to the heart. This is how the lymphatic system constantly picks up excess fluid and returns it to the bloodstream. There are four major lymphatic organs. We'll start with the lymph node. There are thousands of lymph nodes all across the lymphatic system. When there is an infection, lymph that contains the pathogen can enter the lymph node. And when this happens, the cells inside the lymph node sense that there is something wrong and they become activated. So the function of the lymph node is to store lymphocytes and other white blood cells and mobilize them in times of infection. The second major organ of the lymphatic system is the bone marrow. Bone marrow is found in the joints, rib cage, shoulder girdle, and hip girdle. The bone marrow is the place where all blood cells are made. This includes white blood cells, red blood cells, and platelets. The white blood cells that are important in the lymphatic system, such as macrophages, neutrophils, lymphocytes, T lymphocytes, and B lymphocytes, all originate in the bone marrow. The B lymphocytes also mature in the bone marrow. The T lymphocytes, on the other hand, need the thymus gland, which is the third organ of the lymphatic system, for maturation. So the T lymphocytes mature in the thymus gland because the thymus gland releases a hormone called thymosin. The last organ is the spleen. The spleen stores all the formed elements, white blood cells, red blood cells, and platelets. Let's look at how the body defends itself against pathogens. We have three lines of defense. The first line of defense, the second line of defense, and the third line of defense. The first line of defense is what the pathogen encounters first, like your skin, hair, mucous membranes. Those would be like the first line of defense. You want to imagine the first line of defense as your basic security that you see in any organization, like campus security, for example, would be your first line of defense. The second line of defense is what the pathogen encounters after it's gone past the first line of defense. So this would be a little bit more sophisticated. So that might be your police force, could be your second line of defense. The third line of defense is far more specific and it's the most sophisticated kind of defense, and this is like the special forces in the army. So the first line of defense is non-specific. This means that it protects the body against all pathogens. The same goes for the second line of defense, whereas the third line of defense is highly specific. For example, antibodies produced against the COVID-19 virus would be an example of the third line of defense. Let's take a closer look at the first line of defense. The first line of defense are barriers that are already there in the body and is the first thing that the pathogen encounters. So it is difficult for the pathogen to penetrate these barriers and enter the body. So we have three types of barriers. We have physical barriers such as skin, hair, and mucous membranes. We have chemical barriers such as hydrochloric acid, lysozyme, and vaginal secretions that are acidic. And we have physiological barriers such as coughing, sneezing, vomiting, and diarrhea. So let's take a look at each one of these. The physical barriers, we start with the skin. The skin is what the pathogen first encounters, so our skin is our first barrier. The second barrier is hair. The third barrier are mucous membranes. We have 4 tracts in the body that point to the outside, that are open to the outside world. Those are the digestive tract, the respiratory tract, the urinary tract, and the reproductive tract. All these tracts open to the outside world, which means we are more susceptible to pathogens entering. So the mucous membranes release mucus and keep these tracts very slippery, not allowing the pathogen to penetrate the deeper tissues. The physiological barriers are obvious. Coughing, sneezing remove pathogens from our respiratory tract. Vomiting and diarrhea remove pathogens from our digestive tract. They might be unpleasant, but they are there for a reason. They benefit us by protecting us against the pathogen. Chemical barriers, we have many chemicals. HCl in the stomach, lysozyme, which is an enzyme that is found in saliva and tears and nasal secretions. They deter bacterial growth. They basically kill bacteria. Sebum, which is oil that comes along with your hair follicle, also deters bacterial growth. And vaginal secretions, which are acidic, can kill bacteria. The second line of defense is more sophisticated than the first line of defense because the immune system should actually do something to deal with the pathogens that have penetrated the first line of defense. You want to imagine the second line of defense as being a combination of the FBI and the armed forces involved in combat or rescue. We're going to classify the second line of defense into 3 types: protective processes, protective proteins, and protective cells. So we'll start with the protective processes. There are 2 types of protective processes that we will look at. One of them is inflammation, and the second is fever. Both inflammation and fever are beneficial to the body unless they go out of control. The second is protective proteins. Let's look at 2 types of protective proteins. One of them is the interferon, which is an antiviral protein. which we will look at closely in a bit. The second is a complement protein. Complement proteins are a set of proteins floating around in the blood, waiting to be activated by the presence of a pathogen. The third group is the protective cells. We will take a look at two major protective cells at the second line of defense, and they are the natural killer cells and the phagocytes. The natural killer cell is a kind of lymphocyte, and the phagocyte is the macrophage or monocyte.